Okay, so week 12, we're finishing up with health and safety for the house. Next week we'll talk about heat load calculation again. Who's not done with the project yet? One. So definitely.
We started it.
Okay.
Maybe starting it.
You have 2 weeks, and we will go through the book again.
Oh, that was the project I was talking
Yeah, we will go through the heat load analysis calculation. I mean heat load analysis calculation. And I hope we have the H22 book. However, this is the last lecture we have pertaining the book. Then we'll continue with what we started with, which is the heat load calculation. So combustion byproducts usually happens in unvented combustion. So if you have a propane tank that you're using for heating, that's going to cause a lot of issues and trouble for you. If you burn any fire in the house, that will cause a lot of carbon monoxide. Candles produce carbon monoxide. The small salamander heaters that you fire up will cause a lot of combustion. Fire range will cause also a lot of combustion. Gas heaters, combustion gas heaters. Backdrafting can be an issue because if you look at your gas furnace or the oil furnace and look at the fire inside, it's burning continuously. If you don't have enough outlet for that to come out, there's a lot of backdrafting happening. Cracked heat exchanger. This is an issue when you have a furnace where the flue gases intersect with guys, phones off please. Where you have the flue gases going outside, meanwhile it's in contact with the air that's to be heated inside your house. Sometimes a small leak over time, since the draft is very quick, it will seep into your house and it might smell a little bit different, but carbon monoxide is odorless. It smells like nothing. However, it's really, really bad for your health, and we'll explain why. So cracked heat exchanger is another issue. You can visually inspect the heat exchanger and see if it has a crack or not. And sometimes the heat exchanger can look new and sound, but there is a small disconnection between one of the legs and the heat exchanger. Cracked vent or chimney that can cause you to have carbon dioxide and monoxide into your house. Depressurized zone near the furnace. What does that mean? Let's say you decided to install a big vent fan in the basement. That will cause back pressure. That back pressure will alter the balance of pressure inside the basement, and thereby the air will come, instead of going out, will come down into through the fire and into your basement. And this will have some kind of back drafting. Blockage. Chimneys over time, they accumulate a lot of dust and ashes, and eventually it will cause a block. If you have a block, that will cause you to have backdraft and not the ventilator will not be venting or letting the air go outside properly. So backdrafting, you should have a draft between 4,000 to 100 inches of water. We'll do the testing when we do the combustion testing, where you measure the draft over the fire. You want to see how much draft. What is draft? It's probably it's a suction, the amount of vacuum you have over the fire, and then you go over the breech chimney and see what is the backdrafting. So it should be between those two numbers, or between 1 or 5 Pascal. So you want to have enough backdraft and enough suction. If you don't have enough suction inside the chamber, something will seep outside to the house. Example: when you have a bonfire, you see the air coming outside and pulling things from the bottom. And sometimes if you have a fire pit, a big plate, you see they put holes in the bottom, so it will draw air inside. So you can see actually the movement of the air coming out as the air moves outside, and that will cause again some backdrafting and some suction inside the fire. So cold outdoor temperature should produce higher chimney draft. Why? If the air is very cold outside, why would the draft be faster?
Difference in pressure.
Yeah, it's higher. The air is denser outside, and you're jetting a lot of hot air. It's gonna be faster. So the differences in pressure will make the buoyancy effect very high, so you have a lot of pressure coming outside. We measure the difference between the outdoors and combustion zone should not be more than 4 or 5 pascals. So you don't want a lot of back pressure again, and you don't want a lot of pressure difference between the outdoors and the combustion zone to be too high. Why is that? If it's too high, you might again disturb the fire, and the fire will have incomplete combustion. You're having too much air. Having too much air is also not good, because again, too much air, too little air will cause you to have incomplete combustion. So you want to have the right amount of air. So if you have colder air outside and it's the backdraft is too high, you have a damper in there. Otherwise, if there's no damper, then you have a lot of back pressure, and that will cause you to suck in too much air to the chamber. That's why if you look at the chimney, there always a sliding door to allow for this back pressure. So the air coming into the chimney will not come from the fire. Sorry, the back door, probably you've seen it before. So, usually when you have a chimney or a draft, you have one of those doors in it, and if you see it has a weight and it should balance, the pressure goes into the chimney. Because if, again, that is too cold and the air is pulling out too fast, you don't want the air being pulled too fast to come from the fire. You want to come from the outside air, either the outside or the room where the boiler is. Otherwise, it's going to go really fast, and you're going to suck a lot of air inside the fire, and it's not going to lead to complete combustion. CO testing. CO testing, sorry, is the largest cause of injury. It's caused by incomplete combustion. We want to have 0 or 5 to 15 ppm as maximum depending on the situation. In a house that has no combustion, you want 0. It should be 0. No. If you have a fire range or if you have combustion, up to 20 is acceptable. ppm, what is ppm? Part per million. So, and for 50, that depends on what kind of fire do you have and how long is the exposure. But for residential, it should not be more than 20. 500 deaths a year by carbon monoxide, which basically suffocation. Somebody will go to sleep and never wake up, or somebody will be dizzy or pass out, and usually it's due to incomplete combustion. It happens a lot in the winter time because people seal everything because they want to conserve heat. And by doing so, they don't know how much it was in the house. Over time, it can cause symptoms of a flu. You might be having a fever, dizziness, sneezing. You think you have a flu, but actually it's the CO in your house. Depending on the concentration, it might kill you in your house. So symptoms similar to flu. Why is it bad? The problem with CO, it binds itself to the hemoglobin in the blood, and that's the particles of the blood cells that are responsible for carrying oxygen. So it stays in your blood for hours, reducing your ability to absorb oxygen. That's why it's really difficult for athletes to smoke and perform cardiovascular activities. And that's why they started listing the CO amount on the cigarettes. Because when you smoke, you're not actually having complete combustion. So the smoke comes with CO in it, and that CO will stay in your blood for at least 3 to 3 hours after you smoke. So the nicotine effect might go in an hour, but the CO will stay in your blood. That's why smokers usually have low blood oxygen over time. And this is the problem. It takes a long time for the CO to come out of your blood. 3 hours after you finish smoking. So this is one of the problems. That's why vaping is, they say, is better alternative to smoking, because at least you're not getting combustion to your lungs, or you're still getting particles. You're having an aerosol. These particles vaporize into your body. So with combustion, you have more issues because it's uncontrolled combustion. You don't know the temperature, and it causes you to have CO in your body. cause drowsiness, headache, vomiting. EPA put a maximum for 9 ppm if you are exposed to CO for 8 hours. What would you think that would be? Would you have continuous exposure to carbon monoxide?
Short and life.
What kind of work?
Oh.
Kitchen, restaurants, barbecue places, shops. We have a lot of cars, so there's gonna be, what else did you say?
Welding maybe?
Welding, yeah. You have a lot of CO, so that exposure has to be always monitored, and you always want to have a CO tester in your house. And now I think it's the law that you have a carbon monoxide tester in your house or alarm for that. Just sort of smoke testing as well. It's very common in low-income housing because for the same reason, people are very frugal about letting cold air come out. And again, a lot of the equipment that doing the combustion are very old, and all the equipment have lower efficiency. There are digital testers that are very economical. For $10-15 you get a digital tester. In a vented location, you can have up to 100 ppm with no problem because the place is vented and you have more probability of getting oxygen. In unvented locations, you want 0 ppm completely. Should not be any CO. How do you get it? Flame interference, which means the flame is not completely burning, it's hitting surface. If you have flame impingement on the wall of the chamber, you're gonna want to have carbon monoxide. If you have flame hitting the pot that you cook it on, you're going to have carbon monoxide. What else? Dirt and debris. Those can cause also, because you can have carbon monoxide, different debris in the chamber, in the flue, can cause you to have carbon monoxide. Cleaning the walk-in chamber, inadequate combustion air, too little or too high, that will cause you to have high carbon monoxide. Backdrafting, again, we talked about that. The draft is not fast enough, it's backdrafting into your chamber. Tobacco smoke, that's another hazardous thing into your house, and it took a while for the government to decide that indoor smoking is bad for many reasons. A lot of research has been done about second-hand smoke and what they call it third-hand smoke. Third-hand smoke is basically the particles produced by cigarette smoking that sticks to your clothes and your furniture, and can linger and get into your lungs, and it's very, very bad for little babies and elderly. So the smell of smoke is still something harmful for you. You know when you smell something, that means it's a particle, it's a molecule, it got into your lungs. There is more than 3,800 chemicals, but again, it depends based upon the temperature where your cigarette is. And there's a lot of debate came in the 90s about light cigarettes and regular cigarettes, and how if you have a light cigarette, you're gonna drag on it more, so the temperature is higher. What is the temperature at the tip of your cigarette? Hot. What is it? How many degrees do you think is that?
So we heat 200 degrees?
More.
500?
More.
800? 700?
Around 600 degrees. 600 degrees. And that actually fluctuate. Huh? Again, because the material is not that conductive. The same with people touching charcoal, it's not very conductive. Touching the same thing as metal is different. So again, when you drag on a cigarette and it's very lit, that's around like 600-700 degrees. It's really hot. But if you leave it alone, it's lower. And the material is very woodsy. It's kind of like wood. Because wood, let's say you burn it, you really have to move it.
You're gonna have to add weed smoke to this too.
Huh?
You're gonna have to add weed smoke to this too.
Same thing. No, it's different. It's different. This is components.
That's what I'm saying.
Yeah.
Yeah, that's what I'm getting at.
Research is still on. So carbon monoxide, that's something on. So carbon monoxide is going to occur whenever you burn something and you inhale it. Whatever you want it to be, tobacco, cannabis, papers, mint. So anything you burn with fire, it's going to bring carbon monoxide to it. Ammonia, that's something particular to tobacco, and it's something also used to wash and preserve the tobacco. Formaldehyde, it's one of the common things that's known to science that causes harm to the body. Nicotine is, has long-term effect on your body. However, some doctors debate that nicotine is not as bad for you as the other things that come with it. But nicotine is highly addictive. It's not really something you want to have. So the EPA estimates 39% exposure to air your polluted come from tobacco smoke. 1,000 Americans die every day from cigarette smoking. That's, again, this book is published in 2010, so it's still not that current. Luckily, the smoking amongst teenagers has reduced a lot in the last 10 years. 3,000 died from secondhand smoke. That is also peculiar because secondhand smoke is worse than first-hand smoke. 37,000 Americans die every day from heart-related problems related to smoking. So the problem with smoking, that not only the nicotine is bad for your heart, it gives you heart rate, it's the lower function of your cardiovascular system. Your body needs oxygen, your heart will work harder, and your body's not getting oxygenated the way it's supposed to. Nitrogen oxide. So nitrogen oxide, where does it come from? Where does that nitrogen come from?
Air.
Air. How much of air is nitrogen? 80% of the air is nitrogen. We don't use it, we don't need it. It's not something we use. Unless you do screw diving, there's no need for nitrogen. So, if we think that nitrogen is there and we're burning fuel with air, so eventually you are going to burn some nitrogen with air. That wasn't an issue for a long time, but at some point they realized that nitrogen oxide is something that's really not usually in the air, and it's not good for health. It can cause major respiratory ailments with as little as 2 ppm. Some states start to make it low, that if you have combustion, you have to have something called low NOx, and what they call it NOx, because it could be NO2, NO3, NO4, and so on and so forth, depending on how you combust the air, what kind of nitrogen you are burning. Wood stoves can cause nitrogen oxide. Why do you think that is? Not the ash. What else? Think of incomplete combustion. You want complete combustion. So you don't have the right temperature. Wood stove is hard to control the temperature where you're burning the wood, so probably you will have some nitrogen oxide. Cigarettes, again, because uncontrolled and incomplete combustion. If you can't control the cigarettes to burn at a certain temperature the whole time, probably you'll be better off without the carbon monoxide, but you're not burning it completely. Kerosene space heaters, they cause a lot of nitrogen oxide. And they all have VOC. What is VOC? Volatile organic compounds. I will talk about that in the next slide. So they do have VOC and they also have nitrogen oxide. VOC is also very common in solvent, cleaners, paint, and varnish. It's, did I talk about it here? Oh, I didn't talk about it. Same slide. Okay. So VOC is volatile organic compounds, and it's the new car smell. So in the past, when they say, yeah, we love the new car smell, that's basically volatile organic compound that are air suspended and coming into your lungs, and it's not really healthy. They're very common in solvents and cleaners. WD-40 all has VOC. Any kind of solvent. Ethanol has some VOC, it's not pure ethanol. Paint, furniture with varnish, drapes, and draperies and carpeting. So the smell is basically some chemical has been used in the processing, and over time it will still evaporate. So when you have new carpet, the first few days it will smell new. They call it a new smell, but basically it's all the solvent chemical disintegrating. In the older cars and from the 90s and the 80s, they have a lot of VOC in the building material of the car. And for the first 2 years, you can smell that smell all the time. And the problem with the car is that it's very close to your body. So probably you're absorbing it through your skin, or also you're smelling it. So it has been banned in the new cars to have material that will have VOC can be airborne. I'll talk about radon as the last thing. So radon is a natural gas. It comes from the ground. So it's not even man-made. It comes from rocky soil, which is very common here in England. So they didn't discover, they knew about the radon, but they did not know it's very common. It's really hard to test for it. So it causes lung cancer. That's 15,000 lung cancer per year caused by radon from old houses. That's huge. So some places were tested for radon, and people, of course, didn't want to live in those places. So either you have to move or you have to seal the basement. But I wouldn't live in a house that's suspected of having radon gas. It's not going to stop. You will sleep, and if you open the windows, you can have probably some radon as well. So it's an area that you don't want to live in. And again, it's not something man-made. It's always something in the area. This thing is very hard. So by the time you suspect there's radon, it's too late to go out this area. But now I think they know if that lung cancer was caused by radon. The testing required 2 to 7 days testing. You get a sample and you'd be sent to the lab. So it's not something you can get a sensor for. But some areas, some government agencies are using surveying methods to know where the radon is coming from. The best way for the risk, and okay, here's the scary part is, you can be in a house that's radon free, and over the years it develops some radon. Some cracks happen in the rocks, they start seeping some kind of gases, and it will come to your house. That's why people were very, very upset with hydrocracking, which basically trying to use natural gas in the ground by basically breaking up the rocks inside the ground and releasing natural gas and capturing it. These activities can cause some rocks to move more than it's supposed to, and eventually will leave something that you don't want. Some people in I think in Kentucky or Pennsylvania, after hydrofracking, for a while they had gas coming with their well water. Yeah, tap water. You open tap water and you can light it on fire.
That's happened all the
Yeah, you can see it on YouTube. People have the faucet, turn on the faucet, they will light up the water with fire. So gases can come with natural well water. So depending where you live, that's something you have to think about. So as a preliminary mitigation, you can install plastic ground barrier and sealing all the seams for the walls and the ground. Seal the floor in the basement. That's something is the law now for all new houses. This is the least you can do, but at least you can seal the floor so you don't have it in your house. And again, depending on the concentration that the radon comes into your house. Ventilate crawl space or basement to dilute the radon. So if you have a basement or a crawl space, you want it to be ventilated. So in case there's radon, in case your house, when it's space without gas, you can still ventilate and have it not be concentrated coming into your living space. I put a PDF here that talks about radon. I don't know if it still works. No. Let's see. Yeah, if you double click on it, it should open. All right, I will finish some of this on Wednesday. I will start the review for the heat loss. So, thank you.